Just a quick note before we start this episode. I would like to say that this is the last episode of the season. So it's been a really, really good time. We've spoken to loads of different people. Started off with Rulong, who spoke about the Chinese black soldier fly industry. Really interesting. Bob Holtman's then we had a good discussion on the engineering and the climate and the structures involved in black soldier fly farming. Quite a technical episode. Then going into Chris Smits, who is based in the UK, an expert in the waste industry in the UK, the organic waste. So it's a really good case study in how it can work from a feedstock perspective. Then Sophia Katzin joined me on the podcast, who gave me her insights of a career in black soldier fly industry, working as a consultant and also in-house as a technologist, nutrition and breeding. And Aaron Hobbs from North America spoke to me and we discussed regulation, collaboration, bringing people together in the North American industry. And staying in North America, Dave Leterre then joined me and we discussed how you can actually make a profitable small-scale black soldier fly farm, because a lot of people here have been talking to me about this and wanting to know more. After Dave, Heidi Hall, back in the UK, spoke to me, and she works in the pig industry and has worked in the poultry industry, as well as done lots of extensive research on black soldier flies. And gave us an understanding of how we will get black soldier flies into industry. Then we did a bit of a round the world trip on a boat with Morgan Briel and Arthur de Dinichin, who discussed what they're doing with living soils in the Ivory Coast and how they're going to spread the word of black soldier fly farming around the world. That's who we've had on so far. Now, this is the final episode. I won't introduce it because I'll go on to that in a second. But I really hope you enjoy it. If you have enjoyed the season, then subscribe and follow what I am doing on whichever platform you listen to this on. Send me lots of questions. Let me know what you think and stay tuned for the next season. Enjoy the episode. Hello and welcome to the Black Soldier Fly Leaders Podcast. I'm your host, David Taverner, and in this series we dig beneath the surface to uncover what's really happening inside the black soldier fly industry. Hello, this is the latest episode of the Black Soldier Fly Leaders Podcast. With me today is a man called Spring Yang, all the way from China, who has an extremely decorated CV in the black soldier fly world, both academic and commercial. We'll go into the detail in a bit, but also Spring has really, really strong views on how the future of the black soldier fly industry is going to play out. So without further ado, Spring, welcome to the Black Soldier Fly Leaders Podcast. Please, could you start by saying how you got into black soldier flies in the first place?
Okay, thank you, David. My pleasure to go on to this podcast. So I started my BSF career since my junior year in when I was studying agriculture science in Penn State and in the US. I was joining a springboard competition. It's an entrepreneurship competition, and we were asked to design a cultural business, and my idea was to it just remind myself when I was a kid, I was raising housefly maggots for fishing, and I always think this should be something good for the chickens, and that was in Pennsylvania. That's a strong poultry state. I want to do organic pasture chickens with the adding the function of the recycling ideas with the housefly, eating the manures and feedback to the chicken. During the experiment, we were doing the experiment to confirming some of the data. And one of the cage in the lab room got broken down, and the flies released and destroy other people's experiments. And people were complaining, and it made me think. I mean, this might be not the good species for this thing. If in the real big operations, if this happens, I mean, I'll get into a big trouble. But at the same time, I just saw this black soldier fly on the internet, and that was back in 2012, like 2012, and that's only a few publications or informations on the web talking about the BSF, and the author is Jeff Tomlin, and who became my PhD advisors. And so I got connected with him and asked him questions. And my competition, I won the second place. I got the scholarship, but the way that scholarship designed, how to give you the reward, is by you have to, because it's a business competition, you have to develop actual business, and there's a few milestones. Once you met it, and you can you get a portion of the scholarship. So I went ahead and established the business, and we were producing the lava. And when we produce it, and the first business is called Symptom Black Soldier Fly, which is still alive in the current state, and is still alive in the US, but we moved it to the Texas. But at that time, we identify a market, which is the reptile. But the reptile, it's only the live lava, only it's the live insects, and we just focus it, and we kind of nailed it. At that time, I mean, there's only another supplier, which is Phoenix Swamps. Dr. Shepard, who's a PhD advisor of my advisor, Jeff Tomlin. So we kind of like competing on that scale, but it's very tiny business. But we survive, and that
And
was
it's
my.
still going, Spring.
It's still going. It's still going. I
Yeah,
mean,
so
still have
it's,
like
I mean, still going. That's pretty good going for a small business, and you know, all of the other stuff that you are going to talk about as well. It sounds like you're a busy man, but good to identify the market. What did Jeff Tomlin think then? He's the godfather of black soldier flies.
Yes, he is. He is. It's the genius, and he got into I mean, he kind of like figure out how to captively breed the black soldier fly, and that was what helped me. And then I was recruited to his lab doing a master. Then I transferred to a PhD. And during that time, I mean, there's a lot of people coming to consult us on the technology side. And that's what we thought. I mean, we are investing a lot of time into this kind of like helping different business. I mean, solving their problems, and we kind of like do it on the field, but it occupied a lot of our time. So that was my idea. I was talking to Jeff, like, I mean, this time is killing us. I mean, if people are coming to us, why don't we, I mean, start a business doing the consulting, and then we do the Evo conversion systems. That company was under this idea. And so we were offering consultations, and using that fund to do our, I mean, application innovations,
And
which also
what were you consulting on, and who was involved? Was it you, Jeff, anybody
me,
else?
Jeff, and one of the postdocs in the lab, Jonathan K. and another microbiologist from Mississippi State, Heather Jordan, and we have business partners, and Terry Chase. So five of us did the business, and we first got the grant from DARPA because we innovated technology. At that time, the biggest problem in the consistent productions, it's you have to produce a big volume of the black fly, because they only live like 7 days, 7 days on the breeding, and then they will die. And if you want to breed another batch of eggs, you have to go through another 30 days of rearing and pupation, that kind of stuff. So there's only always a mismatch of how much you can produce the eggs and how much you want to produce. So
Spring,
we
I've been there. It's awful. You like get these woke flies that don't want to have sex.
right,
They
exactly.
don't
I
produce
mean,
eggs, and you just don't know why.
they don't. Sometimes they do, and sometimes they just decide not. And at that time, I mean, that's a very limited information on how you can, I mean, force them to do what you wanted to do them, what you want them to do. It was really hard. So we developed a technology called Billet. It was patented in within the Texas A&M system, and that technology, it's we can incubate. We can put the sea lava, which is about like a 3 milligrams size, let them to sleep for as long as 6 months. And with this, another party can, I mean, just produce the eggs and hatch the eggs and grow them into this size, and incubate them to. It's under room temperature. The beauty thing, it's also
Hmm.
they can survive in under the room temperature for as long as 6 months. And
It's suspension then, and you know that
yeah, it's
I know you've
batch,
got
and
the
it's
patent.
quantified. It's a quantified unit. So we were putting for the production system we were doing at that time was like about 10,000 lavas per cup per unit. And we quantify them and they were stored and sleeping in the little cups under the room temperature. Whoever, when you want to produce it, depending on the size of the demand, and in that week, so we just transfer a defined unit, a number of units, put them into production. That just creates a very stable buffer between the egg production and the actual lava growing. So that solved a big problem. And we received a DARPA grant at that time to continue developing it. And we
And
were
Spring, you say at that time, so that was from about 2016, was it?
2016, 2017.
Yes.
And most of it was like, I mean, it's definitely around 2017 or 18.
Okay.
I don't
Sure. Yeah, you
remember the
started
primary.
Evo Con Systems in 2016, so it was after
Right.
the
It was like
yeah, that's right.
2017.
Okay.
So we continue to develop the system. So we were developing in parallel a lot of technology, like equipment,
Mhm.
and how the lava can be grow faster and more stable. And we were distributing this kind of information through our consultation services. And um, that's what I mean, Evo Computer System still, exists right now, but the consultation business, already, it kind of like slowed down, but the business entity is still here. At some point that we switch it to only selling the key equipment, such as the breathing lights, some of the innovative, like small devices. There's a lot of like a small devices, small innovation or inventions from different
Mhm.
suppliers. We kind of like create a marketplace for them uh, to sell on the platform, and that marketplace is still going. But since
Yeah,
the
so I bought that light off you back in the
okay,
day when I started my
that sounds good.
breeding. I don't do breeding anymore, but I did buy that light off you.
Sounds good. Yeah, but and in 2017, I mean, my PhD hasn't finished yet, but I kind of like got the approval from Dr. Thompson. I mean, you need to do. We identify issue like in the lab that we're doing in a small bench scale experiments, but in the big productions, it never. I mean, we can hardly replicate uh, a lot of the information from the benchtop results. I mean, it make me ask to think. I mean, the benchtop scale, it's never gonna transfer parallelly, efficiently to the real production. At that time, that was like 2017. That's a couple of I mean, I'm a Chinese, and there's a couple of China companies from China invited us, I mean, to do experiments in there. So I got the permission to, I mean, bring my projects, my research back in China in the real production
Okay.
scenario. So I went back to China in 2017.
And in 2017, you said there was only a couple of sites producing black soldier flies in China.
Correct. I mean, at that time, I mean, there's
Wow.
agriprotein, that's EnviroFlight. I mean, I'm thinking, I would say in the whole world scale, like that's only a couple companies
It's
active
crazy, isn't it? If you've listened to the first episode of this season, released in December or January, I can't remember. I spoke to Rulong Zheng, and he said that there's over 1,000 facilities in China now. That's
right
crazy.
now.
That's a huge expansion.
Oh, yes. Yeah, I'll touch you base on that. But at that time, I mean, that's first scale, I mean, production in scale, the project, it's in Beijing. I mean, that was built by the company that I work with. It's called JM Green. And I have a blog post about this facility, on Evo Conversion System. So it's a municipal waste processing facility. So the mother company or the owner company collecting waste from the restaurant along the streets in Beijing City. And it's only a couple streets that they have the permission to collect it from. And they can collect over like 100 tons of the material every day. It was my first time to see, I mean, how big the issue is. Because I mean, that's a huge amount of waste that they can collect. And the status of the waste is very, very primitive. You can see, I mean, that's a crawfish head. I mean, that's a fish head. That's a fish tail. You can see, you can basically see, I mean, the food on the table.
Mm.
And that was our starting point. It was the first ever, factories built using the BSF technology to process the waste. And there's no models that we can learn from.
And so what was in those days then, if you had no models to learn from, what was the premise of it? You're taking the municipal food waste. What was the aim? Was it protein? Was it processing waste for us?
it was urgency of it was I would say it's all you mentioned, but I think the biggest issue at that time is the urgency to process those waste properly, so they don't pollute the land. Because at that time it
And
was
was
landfill.
was that was that your priority or was it the government's priority?
It
Who
was
was funding it?
uh it's the owner, but the owner works closely with the government. So it's definitely the whole thing is the government posed such a concern, and the owner saw such a opportunity because the government would pay about 200 yuan, which is about 30 US dollars per ton of the waste collected. He can earn this
Okay.
money, but he need to find a way to process it. And Black
And
Sugarfly
process
was
it for cheaper than that price. Yeah, right.
correct. And that was the starting of how I got into the large scale production. And then we replicate. It was kind of successful at that time. It was my first time seeing tons of the BSF being produced, because back in the US, I was producing only like 10, 20 kilograms of the lava per day.
Yeah.
When
Lab
Yeah,
scale, learning the
yeah, lab
trade.
scale.
Yes,
Yeah,
exactly.
even with the symptom production that we were producing only like less than 100 kilograms. But back in China, like we're processing.
You've got to cut your teeth somewhere, right? And you'd rather cut your
Right.
teeth on something small scale, wouldn't you?
Yeah, correct. And then we come in and we will see like tons of the BSF being produced. And we were thinking, wow, we produce so many and we're going to earn a lot of money. But the reality is no one wants to buy it at that time. Um, it was priced at, only the whole dry lava was priced at like 15,000 RMB per ton, which is roughly about uh, 2,200 US dollars per ton.
Yeah, which is that's that's expensive, isn't it? And
That is
when we're trying
expensive.
to do this on a large scale, then it's got to kind of compete with those commodities, really, hasn't it?
Correct. At that time, the fish meal is not. It's only like $1,500 a ton. And you wanna.
Mm.
And the story was. We were saying it's about replacing the fish meal, But when you can only produce a product that's only like 45% protein, 30% fat, even combined with like 75% protein and fat combined.
So
It's a valuable product.
and it was priced at $2,200. If we use dollars as a common currency that we all know, if it was priced at $2,200 for the dried larvae, was that the price or the cost?
It's the price. It's the price that we want to sell. At
But it
that
was
time,
it was driven by because the cost was too expensive, right? Because it
correct.
was early days.
Right.
And why was it so expensive? What actually, what it would be really good. So as we kind of continue to hear from your journey, how costs have changed across that journey and going into the future as well. Because back in 2017, yes, the industry was really immature and we're still trying to figure out what the best way to produce them is and the least cost way. Why were the costs so expensive back then? What are they doing now? And, what is it like for the future? And the reason I ask this, and it's really important for the overall industry, I think, is we hear all of this doom and gloom, like it's we cannot produce it at the right price. Well, what will be great to hear is how has that cost, how has that decreased over time, and what does it look like into the future? And that's where I'd like to get into your head and understand that a bit more. Yeah.
Okay.
So
Yeah,
what was
that's a very
driving that?
good path. That's a
Yeah.
very good path. And so I will jump into the cost right away. That was so to produce the BSF. That's only we see in three portions. First part is the egg cost, the black certified eggs. So that's the specimens. And the second is the feed cost, and the third is the overhead cost, which includes the labor and the equipment depreciation. Okay, for the
And power
simplicity,
as well, maybe. Does power
power
come into
is
that?
um So yeah, I mean, so that would be five portions. First is the egg cost, and the second is the feed cost and labor cost, equipment depreciation, and the power of the drying. I mean, mainly. So I'll
The
start with
drying.
the egg cost. Yeah, the cost of the eggs. In 2016, the egg cost was like $2 per gram. So that's about 30 cents, 30 cents per gram. Now, but I mean, you would think, I mean, it's not expensive, but it's, I mean, the survival rate is horrible. I mean, when
Mm,
we were, I mean, averaging out on a year that we will see, I mean, at least 90% of the eggs die. I mean, the specimens die
mm.
at, you don't know where, you don't know at where, which step
So actually,
they were lost.
that 0.3 cents per gram, sorry, $0.3 per gram of the eggs, but at 90% mortality rate, actually you're talking at nearly $3 a gram.
Yeah, correct. And at that
Yeah.
time, I mean, even myself, I have no idea because in the lab that we were only doing like I collect the eggs from the tank, I hatch it with my hand, and I just do it with my rearing, and it's very simple. But in the large scale, that you can't do everything yourself. I mean, at least that's a three team of people doing the things for you. And that's some material transformation, transportation. So I'm doing the transportation. It's, I mean, I would say when I look back at that time, we were having no idea. I mean, where we lost the specimens. Now, where with my knowledge today, I look back, it's, I mean, at least 80% lost during the transportations, plus the hatching, plus the hatching, and only maybe like 10% lost during the actual rearing grow up state. And so it was just at that time we were so naive that we thought, I mean, such a simple organisms that they grow so
Mm.
fast and they're easy. Even you pay no tensions on the grow belts. I mean, they just millions of the larvae grow up. Then
Yeah, I
it's
mean,
just
I've
because that
found once you get them to sort of 3 or 4 days old, then it fairly plain sailing after that. The first 1, 2, 3 days of their life, I find, is crucial. You need to be checking them every day, making sure that they're okay and that they've got the right conditions for their growth. You know, you get any kind of like breakdown in power and stuff, then they either crawl out or they dehydrate or they get too cold or they drown or they die or whatever, and they're super fragile, just like human babies. You got to check it. My son is
the
now 1 years
difference.
old, and he's always, I'm checking him all the time. It
Yes,
doesn't
but
stop.
the difference, but that's a big difference. The baby, your baby, you check it, you understand whether he or she
He,
okay, he's good or not, and you understand the demand of his emotions giving you. But
yes,
the BSF like is so tiny, is so numerous that you don't have the idea. I mean, how many you're looking
mm,
at,
that's
and
true.
you don't know how much. I mean, you are checking it every day, but you don't know what you're checking. That's
And
our
sometimes,
problem.
yeah, on day one, you know, they've hatched out, and you kind of have an idea of what you've dosed out, but you can't see them, and it takes 2 days to actually start to notice them and see how they're distributed across the feed and whatever.
Yeah, and yeah, I mean that was totally ignorant at that time that we
Mm.
we calculate. I mean that was the air cost, and
Hmm.
second is the fee cost. I mean we're thinking. I mean the fee. I mean it's a garbage. I mean you are collecting. I mean you collect it with the service fee, right? And with the I mean even it's with the same owner that he is selling the waste to the bulk facility. I mean, with some cost. I mean, you're gonna gain it with some cost. At that time, it was. I mean, even we are only paying for the transportation. That's like $10 per ton, and
Yes.
we
So
yeah
you
we
so
were
you were getting paid $30 as like a gate fee, but then you were paying $10
no. That's
for the
another
transport.
entity. That's another entity
All right.
gaining the gate fee. It's not the BSF entity. So the BSF entity, we're paying $10 for the transportation fee
Oh, right. Okay. Yeah.
to to haul the waste to us, and that's our landing cost for the fee, right?
Yes. And then you've probably got a bit of processing, pre-processing before you treat the black soldier fly.
Yeah, that's a good thing. Yeah, that's a good thing. Yeah, that's a good thing for sure.
You've got extra costs on top of that. So, and then what about the overheads, the labor, depreciation, and power?
The labors, I mean, you have no idea that it's insane that I'm seeing like 30, 40 people running in the greenhouse just to do, I mean, hauling all those lava pans around. It was insane amount of labors involved.
And so what was the model that you were using? Was it in vertically farmed crates kind of thing,
It's
but in a
vertical.
greenhouse?
Yeah, it's a vertical. Yeah, you can, I mean, people can go to the Evo convenience site. I mean, search for Beijing facility. I have a post about it. It's automations. It has automations. We build automation, auto feeding, and the crates were built, I mean, self-stackable, and the robots can, I mean, layer by layer moving it. That's how we imagine it would work. Too many issues because it's the first version of its type. Like that's it was not modified for something else that was sophisticated technology and not already applied in another industry. It was something wholly built from our imaginations. I mean, we design it, and that's automation company. I mean, help us to build everything, a lot of things that we never thought about. Like
Mm.
I mean, there was 4 layers. I don't remember, it was 4 layers or 5 layers of the pants. And we try to feed, I mean, that's robot arms go in and try to feed all 5 layers at the same time, aiming at the same quantity. Like, I don't remember, it was like a 25 kilograms. But in reality, uh, it was never equal, and there's no way to check. I mean, sometimes the bottom pan is already overfilled. I mean, the material is filling out. It's already filling out a different. No. But the first layer on the top is still. I mean, it's still only receiving like 1-2 kilograms because I mean the material is the fluidity is
Yes, yeah.
it's not perfect. It's not water. I mean,
It's not
it's a
consistent, is
slurry.
it?
It's not
Yeah.
persistent, and
Yes.
the pressure is over. I mean, it's and
So
if
so
that's
then
a
so then you were getting all of these kind of, you were trying to automate where you can automate, but you're still using 30 to 40
correct,
people to move boxes and to
correct,
do things. Okay.
yeah.
But
I mean,
you
one
know
thing
that's to be expected in a a new business in an industry where you're writing the playbook. You've got nowhere to learn from, right?
right, yeah,
So it's to be expected, and hopefully with this, as this conversation progresses, we can start to understand how are we achieving the automation which actually works, which takes out labor, rather than kind of replaces manual labor with maybe kind of labor for repairs, for maintenance, for operating the machines, or even just operating for where the machines have a lack in something. You talked about the depreciation as well.
the depreciation, like in normal, I mean, if you buy a tractors, I mean, on your, I mean, EBIT book, you want to depreciate for 8 years. But with the BSF, I mean, no one knows, I mean, the machines would live in such a high ammonia condensed environment. It just, it just rust. It rust in no time. I mean, you want it to work for like 10 years, but it would just give up after 2 years.
Yes, correct. But then I always think this as well, because we don't even know if those machines are the right machines for insect rearing anyway. So, there might be an updated machine, or we might think of a new way to do it. So in 2 years, whether it gets rusted by ammonia or not, it becomes unusable. And so therefore that depreciation cost is huge. And it's kind of like, people say, what's the return on black soldier fly farming? And if you got a return of 5 years, then it might not be enough because the technology advances so much. And you tell someone in agriculture that, and they say 5 years. That's actually really good. Because you look at land, and even though land is an appreciating asset usually, you still depreciate it on the bank sheet, right? And on the loans that you pay for it. And land, you appreciate over a generation, don't you? And hope to pay for that over the generation, because it's a very, very, very stable asset that is going to bring you slow returns every year. It's a different industry, and I think that
Right.
needs appreciating.
Yeah. And I won't go into too many details on what didn't work. I mean, it just can. I mean, with your audience, it's all lectured by industry. I mean, everyone should know what I'm talking about. I mean, there's issues everywhere. And to fix the issues that a machine cannot accomplish, that you have to invest more labors to fix the mistake that the machine does. So
Yes.
You can just
Yes.
imagine. I mean, I was seeing like 30, 40 people running around the greenhouse to, I mean, doing whatever necessary. I mean, the facility works. It
Yes.
worked. It was producing every day. It was digesting the amount of waste that we wanted every day. But it's just insane scenario that it just shouldn't be looking like this. It was never the thing that it was
Yeah. But I think you've got to give yourself and the team a lot of credit for starting somewhere and making a lot of mistakes, because you look back at it and I can see your face, you're cringing just thinking about all of the processes back then. But these things give you all of the learnings for the future. So we've kind of got a good picture of what your process was like, how the power was used and the labor, the cost of the eggs, and then also feed, and how it wasn't really, there was no organization or nothing established in terms of infrastructure. So let's kind of move forward in your CV. And so what did you do after this site?
So we built 3, 4 sites after that. I mean, everyone was improving based on the previous one. Everyone got a little bit improved somewhere, like wherever issues that we found. I mean, they'll exist in the previous one that will fix it to build another one. And at that time, we think the time it's when the whole China is developing the organic waste with the national force. Like that's 30, 40. I mean, the biogas facility being built every year to process a certain city's waste, and they use a certain technology. I mean, whenever they collect the waste, they grind it and move it to a centrifuge. The biogas facility, the biogas production only use the liquid phase. The liquid phase with all the carbs and the some, I mean, limited proteins, and they go to the fermentation to produce the biogas. And the oil phase can sell directly to the biodiesel industry. That's instant money. And the third one that it's the headache for them is the sludge phase, the solid phase. But we call it sludge because it's still, I mean, 70% moisture. So that gives the feedstock for the BSF industry. And during that time,
Really?
yeah, during that time,
That's interesting. Okay.
yeah, but
I've
the
not heard that
numbers,
before. The
right?
only reason I think that's interesting, Spring, is I've been trying to look for ways to work with AD, like black soldier flies with AD, other than a bit of power sharing and a bit of maybe frass into the digester or something. But that that seems like a really, really good idea where you can. So and is that working with the municipal waste? Once you've kind of processed it up, then you centrifuge it, separate out the sludge and the liquids and the oils.
Yes. And it's a sophisticated technology that the China, I mean, kind of like bought the whole thing from Europe. I mean, this technology is very sophisticated in Europe. That's Veolia. I might not pronounce the name correctly, but but most sophisticated technology is from the Europe because I mean,
Yes,
in Europe,
yes, because
right,
of all of the
the biogas,
subsidies for
right.
anaerobic
Yeah,
digestion.
I mean,
Yes.
there's no such a thing in the US as well because I mean, US is mainly landfill, right? And
Yeah.
China at that time, I mean, kind of like within the whole national force, they brought the whole system from Europe, and that's like 30, 40 such a facility being built every year.
Yeah, we put up in Europe, we put up loads of biogas. I think the rationale for subsidizing it was energy security, as
Hmm.
well as dealing with food waste. And so we've got loads of digesters and we're producing a lot of energy as a result.
Yeah, yeah, and that was like in 2018, when the uh, African swine fever. Is that, yeah, you know that? It's the
Yes,
a
yeah. It was
swine
quite bad,
thing.
wasn't it?
It was very bad. So that was the force that driven, because before that, I mean, the government they didn't see the issues of the organic waste because all the pig farms, swine farms, they pay the restaurant directly to collect those waste and feed to the pigs. It was a swine fever incidents that took the government to drive the force of building uh, a very highly surveillance uh, system of the waste management. Every city, basically all the cities above like 2 million populations, they have such a biogas facility
Wow,
over the night. So I would
really?
say just over 1 year. I mean, that's in all the major city, all the waste from the restaurant got to be collected by the waste management company.
Wow.
So this force was, I mean, the movement was so fast, and all the way that collecting waste the waste collection, it was or the source of the fee for the BSF became no problems in 2018 because there's already a company doing the city-wise collections for you, and you can gain the waste from those organic waste. So so since 2018, there's like we can see, I mean, a couple dozens of the BSF farm popping up, and in 2019 it was like there's already like hundreds of BSF farms popping up. Everyone is using different ways. I mean, at that time, I mean, people are using all the ways they can thought about. People want to raise them like a chickens. You can see people want to raise it. Some people want to raise them like a pig. Some people want to raise them. I mean, it was like all over the night. There's like thousands of people, individuals get involved in this business, and that's when the BSF industry got, I mean, driven to the skyline. I mean, it was so popular whenever we host the BSF conference. I mean, that's almost like 500 people participating, and that's
Wow.
another like 2,000 people cannot participate. They are too busy producing. It
And so is the incentive for black soldier fly production in China, does it remain to be because of food waste
yes,
valorization?
that's the driver. That's the driving force. That's the main driving force. Is
And
the
so,
waste.
there's gate fees. The government is paying people to process waste.
Yeah, but it has nothing to do with the BSF industry because I mean, I was saying all the waste comes management business. They are constructed with the uh, PPP structures. So the government is paying for the waste management company, pay for them to collect the waste and process them, centrifuge them.
Hmm.
So they earn this money. So the BSF sectors, they can only gain the waste from the waste management company. So this has associated with the second force of the second cost sectors, which is the fee cost. In 2018 or 19, that's not so many stable BSF company established. They want to, I mean, some of the BSF company can get paid. I mean, they can get the gate fee to receive the waste. Ever since it was only a very short period, and suddenly, I mean, when I was talking about, I mean, thousands of people go into raising BSF. Suddenly, the waste become a commodity. So people are
Yeah.
bidding on the waste. Just giving you a idea. I mean, how many of these centrifuge sludge can generate? So per 10,000 populations, you can collect about 1 ton of the waste from the restaurant. Only the restaurant. And it's not kitchen waste, not from household. Only the restaurant
Per day.
per day. So yeah, that's a China data. Within a city of 1 million populations, you are expecting like 100 tons of the waste being collected from the restaurant every single day.
And how much of that would equal sludge?
Yeah, that's why we're going to, like, the majority goes in the majority. I mean, China, the dietary has. I mean, we eat a lot of soup, and the soup goes into these things. So the majority part is the sludge. I mean that this part is like 60%. 60%, yeah, 60% is the water. Is the water, and
Okay.
in a very good. I mean, at least 60%, I would say, and in a very good region such as Sichuan, that they have uh they have a lot of like a hop hop. Do you know hop hop? I mean, that's like you see this stick of oil floating on the pot that they did the the food for.
Okay. So it's
And
like it's
in those
oil.
regions, yeah, in those regions they can collect over 10% uh, oil from 100 tons. So
Well, wow,
what's
that's a lot of oil.
remaining, normally you can only get 20 to 30 tons of the sludge at 70% moisture for 100 tons of total waste collection.
Okay. So if you're in a city of 2 million people, then you've got 40 to 60 tons
40 tons,
of
yes.
sludge.
Within And for the mass production, with our definitions, you need to be, I mean, digesting at least 50 tons of the waste per day. Um, in most of the region,
But
I mean, in most of the city, they don't have such a, I mean, it's not, you can, I can only count like five cities that you can actually collect 50 tons of the sludge.
But that's just restaurant waste. What about household?
The household waste is not segregated in
Okay.
China waste management system. So
Are there
you
any
can't get it
plans
from
to do
anywhere.
that?
No, that you don't get it from anywhere. Even today, I mean, everything goes to the incinerations. So it's the only thing that
They don't.
segregates.
Do they landfill it at all?
No landfill. I mean,
Is there an
right now,
opportunity for someone to create a business that does this? So
I don't see
I'm
there's such
thinking
a.
in my mind, Chanzi in East Africa. They tried to do this in Tanzania. They tried to separate at source. So they gave people bins to put their food waste in communities where people could go and put their food waste in the bins, but there was no compliance at all. So then what they did, they
Yeah, there's
located
no
a black soldier
compliance.
fly facility on next to a landfill, and they just kind of flagged down one of the lorries and said, "Come to our place rather than the landfill, and we'll segregate everything for you." And so they actually created then a total waste management business as well
Yeah.
as a black soldier fly business.
Yeah. But in China, I don't think that's there's no compliance. I mean, you can't rely on individuals to do this. What if someone, I mean, just drop a bag of used batteries in the pot? I
Yes.
mean, who is responsible for that? It would, I mean, I don't think this system will work for BSF in any countries, not just China.
Okay.
Household, it's not, I mean, it's too complicated. It's not, I mean, I just don't think that's such a you can you can I just don't think it will work. But that it's a total other topic. It's a social welfare topic. Now
Yes.
I'm only talking about the restaurants.
Yeah. Okay.
In the
Okay.
restaurant, the kitchen is more. I mean, it's more. It's easier compliance. I mean, nobody will move from the I mean front desk. Nobody will move anything from the front desk and go back and throw it to the garbage cans in the kitchen.
Mm. Mm.
And
Okay.
it's an easy flow. The waste that collects, it's very clean. I mean, it's easier for, it's safe. That's one argument that always when I was broadcasting the BSF technology and people complain about. I mean your lava is feeding food waste. I mean, how can you say it's safe? Because I mean, you are eating whatever on your table, and whatever you cannot eat, it goes to the waste. And there's nothing else on the thing, and the whole chain it's supervised. I mean, if my waste has problem, it means I mean someone died already on the table.
Yes.
So it's a actually it's a very safe system.
Yes.
Yeah, and so over the past like 6 7 years, I mean that's always more and more and more people go into the BSF. I'll just bring some as of today that we estimate that's 150,000 tons of BSF fresh lava being produced a year in China, and that's our annual capacity. Among that, and that's only three main products. But everything, the first step is produce the fresh lava, right? So remember this number, 150 thousand tons a year, and into
Yeah.
three products. First is the microwave dry whole dry lava that you can see in I don't know in UK that's Amazon, but in the US
Yeah.
Amazon you see I mean everything it's microwave dry, it's puffy, it's golden,
Hmm.
and it can compete directly with the mealworms. It goes to the backyard poultry markets.
Hmm.
And in Europe, the market is the backyard wild birds, the wild birds. So they collect. Do you know this market
Yes. Yeah.
in
Yeah.
Europe?
Yeah. I know it well.
Right. Yeah,
Yeah.
and
We have
so
mealworm as well for it.
yeah, mealworms and BSF. I mean, goes to the wild birds market in Europe and the backyard chicken markets in the US. Among it, I mean, besides these two markets, there's no markets for these products. Because I mean,
Hmm.
it costs 2,000 kilowatts of power electricity to produce 1 ton of dry lava. It's very
Yeah. It's
costly,
quite a lot.
and it's the
Yeah.
most
There's
expensive products.
On a side note, actually, with the wild bird feed, the RSPB in the UK a couple of weeks ago actually made a huge news announcement saying to people, do not feed wild bird feed to birds within the spring and summer months because it's a disease hotspot and they've noticed that a lot of birds are passing, well, I mean, bird flu, all of these different diseases
Mm,
to each other. And one of the main places they pass them on is when they're at the feeder and they're interacting with
only.
other birds. So if you see a drop off in volumes, then that might be why. But I don't know how much compliance people and notice people are going to make towards this. Anyway, sorry. Side note. Carry on.
Yeah, that's a good information. I would say, I mean, 70% of the volume goes to US, the backup poultry market.
Mm, mm,
But there's no growth in these sectors. That's so China every year export about like 10,000 tons of this grade of material to Europe and China.
okay.
But because it's the most expensive product, a lot of people try to compete on it. But whenever new player come in and want to compete, the whole market price drops. So the current price is about 10,000 yuan per ton. I mean, from the farm. So that's about um divided by like 6.8. I don't know, like $700 per ton,
Dollars.
and that's already the most expensive product. Um, and the second one is you don't want it to be puffy and golden. I mean, just hot air dry. It's hot air dry grade product. The product is like flat,
Mm-hmm,
shrunken,
mm-hmm,
but it's a good color product that goes to the animal feed mills.
mm-hmm.
So for the fish meal replacement, and
How much does that sell at?
so that's double the size of the microwave dry. So we estimated that it has like 20,000 tons of the 20,000 tons of this grade of dry lava, yeah, which can use up to like uh uh six six 60,000 tons of the 60,000 tons of the fresh lava. So the first
Okay.
one is 10,000 tons of the dry lava, used up 30,000 tons of the fresh lava.
Yeah.
And the second is the feed grade lava, used up 20,000 tons, and it used up like 60,000 tons of the fresh lava. And the third one is the 60,000 tons of the frozen lava, the whole frozen lava. And this market goes to the crab farms, shrimp farms, and the aquaculture feed as is. And this is the market that the whole China, we see an opportunity of doing this products.
And
If
so
you
what are
don't,
the prices of the feed grade and then the frozen for aquaculture?
the feed grade, right now it's around $1,000 per ton. And it's usually 42% protein, 33% fat. So combined, it has like 75% of usable nutrients, which is a very good thing. I mean, sole ingredients, it has a comparable protein levels than the commercial complete diet for some of the fishes, but it has much higher fat. The fat with the lava, the lauric acid. I mean, that's a lot of benefits like the mid chain
Oh,
fatty
yeah.
acids. It's very good for the fish. That's a couple studies already identified. I mean, like that's one corp that did the research, fed the lava fat, even the fish would even be slimier, because the fat are more absorbable. So the farmers definitely see such a difference. Like they can get like using it. They like using it as
Yeah.
is.
Yeah.
Or there's some feed mill already saw this opportunity. Uh they try to include this BSF lava into their feed stuff. But this is like a B2B, like the farm to another feed mill business. I mean, it also has challenges, like different area, it has a different dietary habits. I mean, they eat different things. Like in Sichuan area, the food is oily, but in the Shanghai area, it has less oily. And the lava, because here over the coast, they eat a lot of shellfish, and in the food waste, there's a lot of calcium, so whatever, like the minerals, and that contributes to the ash level in the
Okay.
lava products. So
Okay.
you don't have, the current situation is that there's like over 1,000 farms farming BSF in China, producing over 150,000 tons of the fresh lava a year. But
Mhm.
it's spread out in like 1,000 farms, and every farm is producing a different type of products, in my opinion, because they're feeding different diet, and the lava is what they eat.
Yeah, so then you're getting massive variability between
Yeah.
different farms.
So this is a challenge for the it just plays against the compliance that the feed mill wants to follow, which is a standardized
Yes,
ingredient. All right. And that's a
that is
couple
one of
years,
the
I mean,
problems.
playing back and correct. And that's a couple years. I mean, this force, I mean, they have been playing back and forth over the past few years. And right now they kind of like they want this stuff because the
Mm.
fish meal it's over. It's somehow I don't know who
Are
played
they
this role.
getting the frozen larvae cheaper than fish meal?
The frozen lava is the fresh lava, just put into the freezer. That's the
Yes.
so that's the
And
frozen.
does it work out cheaper than the fish meal for aquaculture?
They do in a different, but they don't go to the fish. They don't get to the. They don't go to the feed mill. The
Okay.
frozen lava right now is about three. So for the farms right now is around 2,000 yuan per ton, which is only about $300 a ton frozen in the block. So it already standardized in like a 10 kilograms per block. It's
Well,
total
$300
replication
per ton.
per
That is
ton,
reasonable, isn't
right?
it? But
Yeah,
I
that is
guess
reasonable.
moisture content will be quite high, wouldn't it?
To content, yeah. I mean, depends on what you're compared to. I mean, it's to replace the frozen fish block. The fish block,
Yeah.
you know,
Oh, right.
the sardine block. I mean, the sardine block right now in China, it's about 5,500 yuan per ton. And
Okay.
yeah,
Yeah. So
and
it's
this is only
for the
half the price. Yeah, it's only half the price. But for the crab, for the fish block, it's like 6 kilograms of the fish block producing 1 kilograms of the crab meat. But for the BSF, which is half of the price, it's 5 kilograms of the lava
so
producing
it's
one
half
kilogram of the
price,
crab.
and you use less of it as well. So the crab
Correct,
farmers must
correct.
love it.
The crab farm love it, love it. But this is the first year we ever noticed such a trend. So that's what we are doing in this week. I'm traveling in the north region to the Shanghai, which is the main production region of the crab business. So I visited a couple crab farms, and they all give positive feedback about how to use things. We are only producing the frozen block lava. We only use I only know my lava. I mean, goes to the crab farm, but I never know how they use it. So I come to know, I
Okay.
mean,
So you're going to
how
go
they
and
use
see it.
it, right? And go to say, I mean, the data I provide to you, it's my fresh learning today
Mm.
compared to the fish block and the crab stuff.
We won't get too excited then, Spring, because
Yeah.
it sounds pretty good. Sounds very promising. Are you enjoying this episode with Spring Yang from China, Black Soldier Fly World? This is, as I said, the last episode of this season. Again, hope you've enjoyed it. If you have, please remember to subscribe so you'll find out when the next season is landing, and turn your push notifications on, and it will tell you there. And if you want to get in touch with me, then find me on LinkedIn, David Taverner, and you can put forward your name for being a guest on the next season, or if you would like to nominate someone else who you think would be really good and can add a lot of value, then please do share their contact with me. You can find me, as I said, on LinkedIn, or you can type in the Black Soldier Fly Leaders podcast. Back to the episode. So I wanted to get on to more, well, I guess you've just spoken about exactly what you're doing, but what is it who are you working for now? And you've got other businesses, haven't you?
Yeah, I would say, I mean, I have too many business, but I mean,
I'd
but
say, Spring,
the
I'd say
beautiful thing is, yeah,
you've got ants in your pants, or rather, you've got lava in pajamas.
yes. So the way I do business, I put boundaries on every business, such as like the first business. And right now, our definition for it is you're not a BSF production company. I mean, you're a reptile supply business. Yes, you're growing BSF, you're breeding them, you're producing them, but it's not but whatever happens in the business, in the BSF world, it's not related to you. But whatever happens in the reptile business, it's highly relevant to you. And we have Evo as the marketplace. It only sells things. It doesn't develop things. So we are collecting products from different companies. Whoever whoever invented a good usable device that can help the BSF, I will buy it and I would retail, broadcast it because it has its name on it. People will trust this platform. And so I put all the research and the equipment business in another company called Hong Kong SPR AgTech, and its role it's developing, design, and sell the equipment, the actual equipment like the forklift. We modify everything from sophisticated models to make it fit for the BSF. For example, a mixer that it doesn't work well on the mixer that mix the cow feed. It doesn't work well if we increase the grade of material, make it better for the acidic material, and it will work well on the BSF. That kind of stuff that's the equipment company does, and it sells. And we already have like 200 clients, 200 different BSF companies. I would say most of the companies that we know the names about as today. It's
And
our clients.
do you and some of your colleagues, do you visit your clients to help set up?
Yeah, we normally don't. Most of our things, it's plug and play. We don't sell the whole system. It's that more so over, I want to sell my stuff to the company who want to build a fully commissioning projects for the clients. So we want to sell to the equipment company that who wants to sell the commissioning setup to a BSF facility.
Yeah.
We have these two sectors of the clients because our stuff is modified for BSF, and a lot of the equipment company, they want to develop a system works for the BSF. They don't. They lack such a experience. So we do this, but we never. But this company, they produce their equipment, but we never build complete factories ourselves. With this, and myself, I mean, I would say over 50% of my energy was in works in a company that builds the actual factory for waste management company, and I raised most of my lava within this system. So with this kind of like a boundary setting up on everything, so they kind of every entity that I have, it's about BSF, but they don't actually do business together. They're not under one roof, so they try to focus on one mission that they sign up for.
Yes.
The company that actually builds the factory. Previously it's the same group of people. Like first one is the GM Green, which I came back and joined in 2017. But then with some issues, it's a hilarious story by itself. So I will pass that. And then we started in 2020. It's called Blue Protein, like the color blue, blue protein. So our logo is
Okay.
blue.
Okay.
So
And
we
so
with
this is looking more at the present and potentially into the future. It sounds like you've kind of taken all your learnings and you're putting this into building, well, not only supplying equipment and materials, but also building facilities for waste processing companies. What is the kind of model that you feel is the best way forward, and how is it going to bring those costs down?
So, that's a current. We were talking about the five cost sectors. Right now, as of today, the egg cost is 30 cents yuan per gram. So that's only like
Okay, so that's sort of
4 cents, 4 cents, four
four
US
US
cents
dollars.
per gram, $4 cents
Wow.
per gram. And the
Wait,
survival
let's
rate,
just stop it there. Can I stop it there? This is a call out to everyone in the black soldier fly industry. That is your benchmark for today. Can you get it to $4 cents,
I
the
mean,
price of eggs? That's the challenge.
by doing that, I would say the whole China is very different than every part of every part else. Because since 2010, we already segregated into three parts. First, the breeders, they only do the breedings. They don't collect waste and do whatever. They feed them with the feed grade material and and produce the breeder quality of the pupa, and they produce the eggs. Egg is their final product, and they sell to like 10 mass production facility. Whoever that wants to produce, I mean, whatsoever quantity of the waste and larva, they only buy eggs. They outsource the eggs. Nobody produce their own
And
eggs.
what's the key to getting it to that price? Is it because of the volume of demand?
Because the volume and the segregation. I mean, today, I mean, if you are producing like 200, if you're processing 200 tons of the food waste a day, as of today, I mean, you're already the biggest facility in the world, right? But you only need like 15 kilograms of the eggs every day. If you're producing yourself, I mean, the egg production, it's always fluctuating. I mean, you can't guarantee you're getting like 15 kilograms of eggs every single day. But if you outsource it, you depending on a much bigger breeder system that you can guarantee what you're getting. And when the people, I mean, collecting the demand, they just replicate their breeders. As of today, I mean, every day productions over uh, 30 kilograms of BSF eggs. Can you imagine 30 kilograms of eggs? Have you seen it?
Nope.
And there's at least
Nope.
10 facilities in China that can produce this every single day. And they
Wow.
aggregate their capacity, and I mean, everything is streamlined, and that's the way you can, I mean, reduce the cost to 4 cents a gram.
And are they just these breeders? Are they just supplying it in China, or are they exporting as well?
Exporting in China is very difficult. I mean, I know somebody did that, but it sounds like everybody discontinued. It's not worthwhile. It's not worthwhile.
Sure. Spring, I've done a quick calculation as you've been talking, and in 10 years from 2016 to 2026, the real price of eggs is 1% of what it used to be. That's
Yeah.
insane.
Well, I mean, you have
Just
to
10
also,
years.
you have also, I mean, consider the survival rate. Right now, it's not 90% or 80%. That's still
What is
massive.
it?
Average at like 40, 50%. Yeah,
Ah,
so it's
right.
not,
Okay.
yeah, it's not that much. But
Yeah.
it already reduced significantly. But at this price, it's a bad competition. So I don't believe any of the breeding facilities earning the reasonable level of profit that they should be. They are suffering because there's too many eggs
Okay.
and
Yeah.
not enough
Yeah.
demand. So
Yeah.
if the eggs can stay if the eggs can stabilize like in like 8, 9 cents per gram, it would be I mean the egg producing facility would be a very good models as a business, as a standalone business.
You need the demand. Yeah.
Right. Yeah. But another side, so that's the eggs. And the second one is uh the feed. Like I said,
Hmm.
right now everybody is competing on the sludge. The slurry. Yeah, the slurry right now
Mm.
it was like what I say, like $10 just paying for the transportation, right? Right now, the cost increased 3 times. That people competing on the fee, and right now averaging the landing fee for the landing cost for the fee is about $30 per ton. And it normally costs like 5 tons of the slurry to produce 1 ton of the live lava. So 15 tons of slurry to produce 1 ton of the dry lava. That
Yes.
become a
Yeah. That's
higher
quite
cost.
normal
Uh,
conversion. So
yeah,
actually, the feedstock has gone up.
yeah, the feedstock going up. The feedstock right now is overrunning the egg cost, and for the uh, for the labor cost right now. So I don't know if you have seen anything on YouTube. The China production system, we call it the ponding system. The ponding system, POND, like they grow on the ground. So there's no
Yes.
vertical
Yeah.
farming,
Yeah.
no automations, all labors. So averaging this couple facility in China right now can digest 200 tons of the whatever organic waste a day. And to make this system work, it takes about 40 labors to process like 200 tons of food waste a day. And this includes the drying or frozen or whatsoever. So this become
Yeah.
a sophisticated model. So right now, the live lava production cost as of today in China can be about uh, $280 per ton with everything calculated, with even the facility, the, the buildings depreciation,
280 per
280 per
280
ton
to
of the live lava.
yes, okay. Wow.
Yeah,
US dollars.
US dollars.
As a percentage, how much of that is the depreciation?
Less than 10%. Because I mean, you
Okay.
can go. Yeah, I will share some links. And
So
that's
so
how
the main costs there would be feed
the main cost
and
is the
labor.
cement. Okay, yeah. You're talking about the cost on
Sorry,
the
for
lava.
the
Yeah,
total for the
yeah,
$280. Yeah,
yeah. The main cost is the fee cost. Yes, it is the fee
the
cost.
feed cost. And that feed cost is not so much the problem of the black soldier fly company. Well, it is, but it's more of a market forces issue.
Yeah, yeah. It's a market force, but that's no.
So
But this sector won't grow much bigger because I mean it's already competed in such a level. Like every city's organic waste is already competed up. So that's
so is there an opportunity here for different feedstocks?
correct. I mean
What
the
what
next
about what
level
about
if China
manures? Is there opportunity there?
manure manure is definitely the next step. So chicken manure is definitely good. I mean that's like billions of chickens in China, and that's like
Yes.
I I don't I can't know. I had the number, but I don't have. I mean that's tremendous amount of manure. I mean that can be
And
access
what
to.
what happens to that now?
They cement into the organic waste. I mean there's already had the certain ways of doing it, but it's by equipment. So equipment they will be depreciated out. So that's an opportunity when the first batch of this kind of equipment burn down and BSF can access to. I mean, as of today, I mean, that's already too many manure can be processed by BSF. That's not from the mega facility. The mega facility, I was talking about the chicken. The chicken facility, if you have only like 10,000, 20,000 chickens, the manure is typically a problem that you can collect. You can get like 200 tons of the weight, the manure. I mean, or 20 ton of the stuff from um, but the mega X facility, if you have uh, like a half million boilers, you usually have a very sophisticated system on site to process those manure, and those sources chicken manure cannot be accessed to the BSF's sectors today. So so the biggest challenge right now in the BSF's sector in China is the feedstock. I mean, I'm jealous to the European peers that they can use the brewery waste. They can use the wheat bran. I mean, they can use I mean, there's some pasta, the waste from pasta companies in China. I mean, you won't be able to think any of this. I mean, the brewery waste. I mean, that's like a millions of pound waiting this to be
Yeah,
fed,
yeah.
and they're lining up to pay cash to get this. And the pasta stuff. I mean, the swine farms love them, and they can pay much higher cost than the BSF. So
Yeah, yeah.
the yeah, and there's just too many animals in China that they're competing on those nutrient sources. China as a whole has a huge deficit in the protein. So the only thing that I see the opportunity in China is the manure. The manure is a big problem.
Processing the manure. Yeah, but if you've
Right,
got too much of it, then absolutely. I see it as quite a big opportunity here in the UK as well, actually, and because it's causing a lot of pollution in the rivers and the air as well, I suppose.
right,
So the different country, different problems, but same solution,
right.
perhaps.
Yeah.
Yeah. Um, One final line of questioning. So you've gone from $2,200 per ton in 2016 to now $280 per ton. Of that $280 per ton of live insects, obviously.
Correction. So the 22,000 per ton is the dry lava. So
Right.
$280
Okay.
per ton is live lava. So if you wanna, so our calculation is like 280 times three plus $100 of the drying cost. So that's the cost of the dry lava as of today.
Yes. Okay. So actually yes. Okay.
So that's
So
about
you're
$1,000.
talking
So
sort
only
of
half
towards
it.
thousand
Yeah,
dollars.
right?
Yes. Okay. So it's gone from $2,200 to $1,000, but that's still progress. And if we're saying a big proportion of that is the feedstock cost, then there's potential to shift from the current system of $30 per ton to chicken manure or different manures. I want to talk about the labour. So what is you said it's a pond system where you still are using 30 to 40 labour people for the production. Is there any way to reduce that labour usage down by automating a simple pond production system?
Good question. That's also a topic that we are trying to resolve. I mean, in the ponding system that you go on the bed, and it's a cement floor. The cement floor will absorb a lot of heat generated during the lava rearing, and it was the heat that can evaporate the water from the substrate to the air and making it dry. And it needs to be less than 30% moisture content for the frass to be
That's
siftable.
the frass.
That's the frass.
Yes.
Yes.
Yeah.
The frass needs to be siftable.
Yeah.
It needs to be below 30% moisture content. But in the ponding system, it never gets down 60%. So slurry in is a slurry out, and it's not siftable. I mean, China's so smart. So the way that we're harvesting it is, so we cover one layer of the mesh. The mesh is, I mean, it has holes in it, right? It has holes in it, and then above the ash, we cover a sleeve, solid sleeve. It creates a suffocations in the frass. So the lava will crawl, will try to escape. So they will go through the mesh and get trapped by the sleeve on top. So you just like rolling a cover, then you can collect most of the lava out. So we don't require.
Just in this quite simple. Wow. Wow.
Yes,
That's very smart.
it's very smart, and it can be done in whatever scale. Like if you have like only 100, 200 kilograms of the frass on the ground, you can suffocate the lava out.
Just to clarify, so it's 2 layers of cover. The bottom layer has small holes that the larvae can crawl through. The top layer is completely solid and traps all of the air.
Correct.
So the larvae
Yeah.
then crawl through the top hole and then encounter this new layer which they can't get out of.
Right. And you just roll it like I don't know, like this, whatever. I mean, it's a sleeve that you just roll it, or you can just put it aside. I mean, the mesh can somehow hold the weight of the lava. It's a thin layer, but
So Spring, could you use the sludge for the next lot of larvae?
no. That's frass. That is just wet.
They won't
frass.
digest that.
They won't digest. I mean, it's already digested. I mean, the earthworms can eat it, but that's not enough earthworms that can digest this amount of waste.
Okay.
The lava cannot redigest.
So then what do you do
frass.
with that sludge, the frass? What,
That
you've still
sludge,
got a
I mean,
problem with all of the organic waste.
Yeah, the organic fertilizers factories can use it as an ingredient, as their nitrogen source. Right? They can replace their whatever, like the chicken. So the ideal theory is there's so many, that's like one chunk of the chicken manure volume, and processed to the BSF, it becomes 50%. The volume reduced by half, right? And the used to the chicken manure goes directly to organic fertilizer facility. But now, after processing by the BSF, it goes to the organic fertilizer facility. I mean, the capacity of the organic fertilizer facility double, because I mean the nutrients got condensed in the frass, and they can produce better products and whatever. But that's the ideal. Right now, we are still trying to prove this value chain to be viable.
Yes. Okay.
There's still a lot of
still quite a
education
bit
to be done. Yeah.
Yes. Is there any other way that you can automate your pond system?
Yep. I mean, that's one thing that already been done. Like in the past 2 years, it's like the shovel, like a small cart collecting like a 200 kilogram of the waste going in, and a shovel into the pond for the feeding. In this year, that's a lot of tractors being used just to load the whole bag with the tractors, and there's still there's some device. There's some cart that can hold 2 tons of the slurry, and has a spinners to spread the waste along the pounding is like 100 meters long and 5 meters width. So it's like a long pound that they just spin it along the side when the feeder cart goes out. So it's so that this but the amount of labor that I'm talking about is already after this step being done, after this automation is being done. Because I mean the most people that we use is like that's at least 16 people. That's per 100-ton waste. That's at least 8 people that does the mash collecting step. So every day from 6 a.m. to like 5 p.m., the only job they do is they cover so that you can cover 100 meters in once. That would be too heavy. I mean, nothing can handle that. So they cut it into like 5-10 meters length. They cover 5-10 meters and wait for 10 minutes and they
Yeah.
collect it. And so every day they just, collect the roll. And this pace is acceptable. And you would think, it's a lot of people, like 40 people, but we're talking about collecting, up to 30 tons of the lava a day. That's with this
Wow.
output.
Yeah,
So
that's a lot.
that's less than 2 people per ton of lava output. So it's already acceptable from our our calculations. This model, is scalable, but we won't see a facility that can process 1,000 tons of the food waste a day. First of all, there's no such a city has such a big population to produce this amount of food waste.
Spring, I've got. I said one final question before, but this is one final question. What's your vision for the global industry for black soldier fly?
Honestly, I should be optimistic, but honestly, honestly, I think only when we can solve the feed issue, like that brings to my major point is that do we actually live in the world that needs protein? Are we actually in the protein deficit situation? And if so, why are we so difficult to get proteins to feed our larva? And why the larva has so many challenges of being accepted by the industry. So I think that's the ultimate confusions in my.
Do you think in some circumstances the protein is a burden?
I kind of think so. I think right now I don't believe. It's my belief that in some days that the human will facing, like a protein deficit situation. But seems like as of today, it's just protein allocation issues. Like we have enough food, too many foods to be eaten in most of the world, but in Africa, there's still, malnutrition's happening. But in most of the world, that's already too many protein exist in every grocery store.
So it's a matter of the protein. It's not protein production; it's protein redistribution is the problem.
You're right.
So then, how does that work into the vision for black soldier flies, or how do we course correct so that the industry is taking the right path?
Yeah. So I would say 10 years ago, I had a dream of building the business, to um, to solve the giant waste issues that we thought of, and then we can develop this technology to to build a company facility across the world, every corner, like the BSF eating up all the waste, whatever organic waste that can do. But I mean, it's like but right now I'm thinking that wherever it has organic stuff, I won't even call it a waste because it seems that every waste is not a waste. It has some places to go. It has everything can find its own field of applications. So, and for the BSF that if we're aiming to feed another animals, so we can't feed stuff that can be fed directly to an animal. The value chain will be broken.
Mm.
It doesn't make sense, economical sense. For example, like the brewery waste, the cows, the sheep, the goat can eat them directly. Why feed it? Why going through a layer of BSF? We thought brewery spent grain it's a waste, but it has its own useful spot. I mean, some animal can use it directly. So it's not a waste. I mean, the waste issue somehow we are thinking it's like a force. I mean, I've been out of the academia for too long, but if we call it a hypothesis, it's like something that we imagine. It's not true. The world maybe uh, they don't have so many waste as we can see. Even the waste, even there's a waste, for example, in the US, the landfill is much cheaper. Um, I mean, compared to if you feed them to the BSF. I mean, with the transportation, everything, if the waste collected from the grocery stores, it's cheaper to haul it into the landfill. They won't go to the BSF. I mean, that's why I think in the current world, in the current time, the US BSF business industry is not booming. The major market is in the US for the dry product that I mentioned before, but there's no production over there because
Mm,
this technology is not needed. I mean, that's a cheaper applications such as landfill and mainly
mm,
landfill. It's so strong. It's so cheap in the US. So there's technically no waste in the US. Everything can go through the landfill
mm,
for as cheap as you can think of. And the second is that do we actually live in a world that needs actual proteins? And as of today, maybe not. I mean the lava, if that's a deficit in the protein, I mean the lava would be so I mean, I mean, corrected pricing. I mean, it's on the value, it's like it's at least, I mean, if you don't agree that the lava is better than the fish meal, the lava meal is better than the fish meal. But I don't think you could argue that the lava meal can be at least 70% good as the fish meal. So why not the lava meal? It's 70% of the price of the fish meal. In China, the pricing system is like right now, it's only 60%. It's only 50% of the fish meal's price. That's how the lava meal being priced as of today.
I think it's finding the use cases into aquaculture has been
Right.
few and far between so far. So, like, the example you gave with the crabs, if that is true and the data persists like that, then it's a really good case study to get it in. I know there's lots of
Yeah. In that scenario,
other
also, I
applications
mean,
as well. Yeah, and
yeah.
we just need more of this data to encourage the use of insect meal versus fish meal or larva versus fish meal. So we just need more data. We need more confidence because the feed is pretty much these fish aquaculture companies. They're selling
Mhm.
fish, right? But they're basically just processing feed. Feed is their business. If they get the feed wrong, they get their business wrong. So they need the absolute confidence of getting the right nutrition in for their fish or their crabs or shrimp or whatever it is they're producing. That's my view. Spring, we've recorded a lengthy episode. It's probably the longest episode that I've done. I've enjoyed every minute of it. You've got some really, really good insights. Thank you so much for sharing all of your knowledge and experience with me and with all of my listeners. Thank you so much for coming on the pod.
Sure. I mean, it's my pleasure. I mean, you asked very good questions, and I've never done a podcast before, and hopefully that I convey the information right. I don't be wrong. I mean, I'm optimistic on the BSF, and I just think that's still some educations should can be done to making more people understand the processes and the market and finding and hopefully can find more applications still for the end products at the BSF.
Brilliant.
And that's
Thank you very
yeah,
much, Spring.
that's the job I'm doing. And thank you very much, Dave.
No worries.
Okay.
That conversation was thrilling, wasn't it? And I hope that you've made it this far because it was a long episode, but it was worth it. I thought it was really good to see and hear of Spring's rich history in this industry and just how much the cost has reduced, even, in China where he was saying the cost was quite high to start with, as we see around the world, but how much it's reduced down by just over half just in 10 years. And just some quick calculations, half of that cost is the feedstock, which is based on market forces and flooding of the market. So, if we can copy this model, if we can get to the scale in terms of like a countrywide or regional wide scale, within the different areas of the world, wherever you are, then it's not just individual scale, it's the collective scale, which is important. That drives the price of the eggs down. It drives the price of the process down. And then it's just, working with market forces on the feedstock. The spring was very optimistic at the end, but also spoke with an element of caution, and it all kind of revolves around the feed and how you use the feed. This is absolutely critical in the industry. If you're using feed that can be done for use for livestock, then forget it, because you can get a far better price or usage in terms of that biological conversion, just feeding it direct to livestock. So you need to find problematic feedstocks in your area. For me in the UK, there's manures because of pollution, there's food waste because, high landfill costs. Finding things that other animals can't outcompete you with, and things that will solve problems, in my view, and what Springer said, is the way forward for black soldier flies. And if you can find those problematic feedstocks, then you are adding value to wherever you are in the world, to someone, whether it's a government, a business, a collection of people. Then you are adding value to them, and then you are using that as your business model, and then that kind of the half of the total cost of production that Spring is saying is in China is a feedstock. That doesn't become half the cost if you are solving problems. So let that be a lesson that you need to solve problems with this black soldier fly to bring the costs down, to do it right. And look, I hope you really enjoyed that episode just as much as me, because I thoroughly enjoyed it. It's really important, some of those lessons learned in this episode, that more people learn them. The more that people learn them, the more this industry can grow, it can get investment, it can change the regulations so it is conducive to what you are doing in your regions. So please share this. This is not just for, increasing my podcast numbers. It is for collaborating, it's knowledge sharing, it is bringing people along the journey and showing what is actually happening in the industry. And that is really, really important. And so I encourage you to do that, share it with your friends, and improve my ratings so that it boosts up the rankings on Spotify, on Apple Music or Apple Podcasts and YouTube and however you're listening to this. But thank you for listening. I hope you have a lovely day, evening, morning, wherever you are in the world. Thanks very much. Goodbye.